in looking at it as a single surface. So now I'm going to go back and re-render the exact same. But I need to assign the glass material. So there's a couple of basic materials, built-in glass materials. We're going to use glazing double pane low E. So you'll notice the number 65. So this actually cuts out a fair amount of light. We're not really aware of it because we're always looking through glass. But architectural glass actually cuts out a fair amount of daylight. So let's try re-rendering this now with. Okay, so it looks about the same. Now remember that the rendered, like, realistic view of this, Radiance alters it so that it kind of looks right. But now if we go to the false color image, and so now if we compare this to, what was that earlier one? Oh, I think I erased it. So by default, Diva saves the images that you've made in, if you go to your main folder, it makes its own Diva folder here, so interior test Diva. And if you look under visualizations, it saves a version of everything that you've rendered. Unfortunately, I think it overwrites, let's see. It saves at least a .pic file, which I think that we can open up our previous one. And okay, so this is the false color version of the one without the window, the glass in the window, and this is the image. So you can see that it's because we're comparing these with the exact same scale. You can see that the window has cut down significantly on the amount of light coming through the window.
Wow.
Okay, so what else can we do with Radiance besides just making renderings? So I'm going to show you guys how to make what's called a node grid. So I'm going to select my floor and click on nodes. It says pick one or more planar surface which will be subdivided for lighting analysis. So I'm going to pick the floor and then enter. So enter distance of sampling nodes off of analysis surface in your modeling units. So why do you think it would default to 2.5? So we're talking about we're
Is that 30 feet standard? Only 30 inches?
exactly, yeah. So this is a standard desk height. So distance between calculation nodes. Let's do 1 foot. Oops, it looks like it put them below. So let me delete that. And let's try it again. I'm going to do negative 2.5. Let me try. So surfaces in Rhino by default have a direction to them. So you can find that out by doing DIR. So it's probably basing the distance of the nodes by the direction. So let's you can flip the direction by using the flip command. So now if we do DIR, it's pointing down. So let me flip this again, and I'll try nodes. Okay, so now I have a field of nodes at 30 inches off the floor. So now if I go to metrics, and I go to daylight grid base up here, and I'm still interested in illuminance. So let's look at illuminance. We'll use the same time that we used before. We'll keep it in lux because that's what we had, and then let's run this. Okay, so by default, you have a couple of options for the color schemes. Let's load this and see what happens. Okay, so what it does is it gives us an actual object in Rhino that has the colors, and it gives us like a little scale. So this is useful because now we can start to look at this. I'm going to hide my ceiling in more standard architectural views like plan view. So if we're looking at this, we can see that next to the window there's a bright spot, and then as you go farther from the window it gets darker. It's still not giving us that much. So let me put the ceiling back. And let's try running this again. So I'm going to restrict the scale here to be between 0 and 1,000. So now if I hide my ceiling, okay, so this is more detail now. So we can start to see the difference between the very bright spot here and, for example, the corners. Now, remember also that this is different than what we would see on the floor because it's looking at the daylight as if there were a desk in that location. So why would a grid be more useful than like a single image?
Probably for where you can actually relate that back to within furnitures or decor just to see the orientation and scale.
Right. It also allows you to look at the plan for an entire floor. So something that you couldn't easily see in a rendering, you can do a grid that covers the entire plan and see what the difference between rooms on the north side and the south side are. And then if you ran a bunch of these at different times of day, you would get an accurate idea of the changing changing lighting patterns. So you could duplicate this grid and the plan and actually see what the daylight results are for that time of day.
Can you do it in section?
That's a good question. Let's see. I believe you can, but so I'm going to do nodes. Okay, so let me see the direction. So I'm going to flip this surface as well. So I'm going to make it a grid of nodes corresponding to the wall here. And I'm going to do it 5 feet off the surface. So roughly in the middle of the room, and then again on a 1x1 grid. Okay, so now we have a grid that roughly corresponds to a section. So let's see what happens. And again, I'm going to choose between 0 and 1,000. And I'm going to go to a side view and hide that wall. Oops. Okay, so what we get is, let's think about this. So we get the light, the direct light coming in the window. We get the indirect light coming in the other window, and we get light bouncing off of the floor here. So yeah, what's something that you could... I mean, it would be useful, for example, if you're interested in light falling on a surface throughout the day, that you could do a grid on that wall and sort of see how the pattern of light moves across the surface. I don't know that I think that the grid tends to want to be mimicking a surface. So if you're just thinking about it as a section, I don't know that that's giving you the correct idea. of a section through the light in the room. But if you're using the grid to measure light on a wall, that would be useful.
So basically, could you do like a section view of the 3D perspective view? Would that make sense instead of as a grid?
A section view of the 3D perspective.